Okay, welcome back everybody. So we're going to continue looking at examples of how to use the law of sines. And in these next few examples, instead of giving two angles and a side, you're given two sides and an angle. Okay, so the strategy, of course, is going to be a little bit different. For example 3 here, we have A is 3, C is 1, and gamma is 60 degrees. Okay. Well, gamma is opposite C, so we know that the sine of 60 degrees divided by C is equal to the sine of alpha, whatever alpha is, divided by 3. Okay, so the law of sine says that. Well, what this means is we cross multiply, we get, or just multiply both sides by 3, we get 3 sine of 60 degrees is equal to the sine of alpha. And if we compute this on our calculator, this is 2.598. And so that's equal to the sine of alpha. And if you look at that this should be, something should be wrong here, right? Because the sine of anything can't be bigger than 1, right? So right now there's no solution in this case. So there is no solution. There is no triangle where with these two sides and this angle. If you try drawing a picture of this, and you'll see why. Okay. So there's no solution in this case. Now let's look at example 4. We just changed the C from 1 to 5, and now let's see what happens. Well, once again, the law of sine says that we have the sine of gamma divided by C, that's the sine of 60 degrees, divided by 5 is equal to the sine of alpha divided by 3. Okay, so we've just had the same as this. We just changed 1 with 5. Okay. Now in this case, this means that the sine of alpha, well, we can cross multiply and we get 5 times the sine of alpha is equal to 3 sine of 60 degrees. So this means that the sine of alpha is 3/5 times the sine of 60 degrees. And this time we get a number that's less than 1. Okay, in fact, this turns out to be 0.5196. Okay. All right, so we want to say, okay, so which angles have sine equal to this number? Well, of course, we can take the inverse sine of this. And that gives us 31.3 degrees. Okay, again, make sure that you are in degree mode when you do this. But then there's also another angle that we have that between 0 and 180 degrees. Because remember, if we go back to our unit circle, and here where the y-coordinate is 0.5196, we have an angle here, but we also have an angle here in the second quadrant, right? And if this is 31.3 degrees, and then the gap from here to here is also 31.3 degrees, okay? So the second angle is going to be 180 minus 31.3. Okay. So we can see that alpha is going to be either 31.3 degrees or 180 minus 31.3 degrees, which is 148.7 degrees. Okay, now let's see. So we might have two solutions. We'll see what happens. In the first case, if alpha is 31.3 degrees, then but let's find beta is, by just knowing that the angles add up to 180, is this. Okay, so this turns out, I guess we, this is going to be 88.7 degrees. All right, and then we can use the law of sines again to find what b is. Well, sine of 88.7 degrees divided by b is equal to, we'll just go back up here and use a sine of 60 degrees divided by 5, okay, and we'll see that b is going to be, well, we can cross multiply and you can divide by sine 60, so you'll get that this is going to be 5 sine of 88.7 degrees divided by the sine of 60 degrees. Okay, and on your calculator this is approximately equal to 5.7. Okay, so that's one set of solutions. One set of solutions would be alpha equals 31.3 degrees, beta equals 88.7 degrees, and b is 5.7. Okay, now what about this other possibility for alpha? Okay, I didn't leave us enough paper, so let's just turn this over and say what happens if alpha is 147.7. Well, you'll soon see that this is not possible, because then in that case, if we try to find beta, we get beta will be 180 degrees minus 60 degrees minus 148.7 degrees, and that's going to be a negative number. Okay, that's way too much. Okay, you won't get an angle. Beta is supposed to be between 0 and 90 degrees. So because of this is negative, there's no solution here in this case, for this case. Okay. All right. So back to this. So this is the only solution for this problem, for example 4. Now we could have two solutions though, and that's what's going to see happen in this last example, or this next example, example 5. Let's try to do this again. We see that alpha corresponds to a, so we can use the law of sines and find what beta is. So the sine of 35 degrees divided by a is equal to the sine of beta divided by 8, which is b, right? And I should say that a is 6, so I should have written 6 here, because we know what that is. And so this tells us that the sine of beta, if we cross multiply, we get the sine of beta is going to be 8 times the sine of 35 degrees divided by 6. Okay. And I won't write this intermediate step because I know you're capable of writing cross multiplying and then dividing by 6. And then we compute this on our calculator, and this is going to be 0.7647. Okay. So once again, we take the inverse sine of that. And it's probably a good idea if you take even more digits than that, because usually in your calculator you can go directly from here to here, just take the inverse sine of answer or something. So you have more accuracy that way. But okay, so this turns out to be 49.9. Okay, and here we are. So we have 49.9 degrees, and we find the other angle is going to be 180 minus 49.9, and that turns out to be 130.1. Okay, so let's consider these two cases. So these are the two possibilities for beta. Okay, so if beta is 49.9 degrees, we get, we want to find what gamma is. Gamma is going to be 180 minus 49.9 minus 35. And this turns out to be 95.1 degrees. Okay, so that is, now that's acceptable, right? Beta could be bigger than 90, right? Especially if the other two angles are less than 90. So Then so now what we have is we can do sine of 35 degrees over 6 is equal to the sine of beta divided by, what are we trying to, gamma. So we're trying to find c, so gamma. Sorry about that, it's distracted. Let's try again. Okay, so this is sine of 95.1 degrees divided by c, and then c is equal to, we cross multiply and do that stuff, we get 6 times the sine of 95.1 degrees divided by the sine of 35 degrees, which is 10.4. Okay, so we have one set of solutions. We have beta equal 49.9 degrees, and c, and gamma is 95.1 degrees, and c is 10.4. So that's one possible solution. Now let's see what happens if we use the value of 130.1. Okay, so 130. So now if beta is 130.1, then gamma is going to be 180 minus 35 minus 130.1 degrees, and this is 14.9. So this time, unlike in the other example, we get a number that's positive between 0 and 90 degrees. So that's acceptable. So now we can just go ahead and find, say, the sine of 35 degrees divided by 6 is equal to the sine of 14.9 degrees divided by c, and then c will be 6 times the sine of 14.9 degrees divided by the sine of 35 degrees, which is 2.7. So we get another solution. Beta is 130.1, gamma is 14.9, and c is 2.7. Okay. So basically we have two solutions for example 5. Okay. So this happens. So when you're in this situation, you could just, kind of like the quadratic formula, you could have 0 solutions, you could have 1 solution, you could have 2 solutions. You just have to, keep in mind, when you take the inverse sine, you have 2 possibilities, and then they both might work, or none of them, or maybe only one will work. All right. So let's take a break here, and we'll finish it up in the next video.